Okay, electric field problems. I'm going to try and make a speed slide here. So I've drawn 3 figures, and I'm going to go through these quickly. And if it's too fast, you need to go back and review about electric fields and the 4 videos posted last week. Solving problems with electric force go much slower. So first problem is a linear charge arrangement. We want to find the field at P. There are 3 charges, Q1, Q2, Q3. As you see up above, all Q's are equal in magnitude to Q. So these are all equal in magnitude. There's 2 positive charges, 1 negative charge. So there's going to be 3 vectors. And I'm going to show those vectors side by side. Q1 is the furthest away, so it's going to be the smallest. So I'll draw that. And this is an electric field. Remember, there's no charge at P. We're talking electric field. And so this is E1. I know that the biggest force, let me skip ahead to Q3. That's also positive. And that's a distance D, right? A distance D from the point. Remember, this is just a point, no charge there, which is 3 times as far as it is from Q1. So this has to be what? 3 squared, 9 times bigger. So this vector, I'm running into my script here, but you can see what I'm doing, is 9 times longer, and that's E3. And then going in the other direction, because Q2 is negative, that'll be an electric field goes toward the negative charge, and that's going to be 4 times weaker than E3, so it should be 1/4 of E3 and a little bit more than double E1. So these aren't exactly to scale, but that would be my E2. Now to add these, remember, there's going to be 3 vectors. I'm going to squeeze this in here, so watch carefully. The E total, I'm not going to write this out, is going to be E1 plus E2 plus E3. E1 is equal to, this is a summation, K Q squared over D squared in the I-hat direction. So it's positive. These are all on the x-axis. 2 is negative. So I'm not going to put the I-hat in here because this all is going to be I-hat and I'm running out of space. E2, can you write it down? Pause the video, write down what it should be and see if you can get it right. Okay, you're back. So this should be K, Q squared. Let's go back to the other one. I made a mistake. I'm going to erase. There's only one Q. I'm thinking force. You see the mistake I made? This is electric field, so there's just Q. Okay, I erased that. So second term, E2, KQ, that's the charge over the distance, 2D squared, or 4D squared. And that's negative. And then the last one is positive, and I'm not going to fit it, so I'm going to say what it is. It's going to be KQ over 3D squared, or 9 3D parentheses squared, or 9D squared. So we did a problem like this. The answer, I'm going to bring it down here below the line, would be 1 minus 1/4 plus 1/9. All times, I'm not going to write it out, KQ over D squared. See if that confirms with what you thought it was, assuming you did it on your own, which I hope you did. Okay, let's skip ahead to the second one, the triangle. So pause the video and draw in all the electric field vectors. I won't tell you how many. So pause the video and create this diagram, draw in the electric field vectors, and then come back. Okay, you're back. So you should have an E2 in this direction. That's the electric field due to charge 2. Positive charge goes away from the charge. And you should have an E1 in this direction. And the magnitude of those two arrows, those two vectors, originating from point P, should be the same length. But you can see, to add these two vectors together, we have to use IJK notation. And so we need to find the y component and the x component of E1. And notice this is a equilateral triangle. Maybe I didn't mention that. So this angle is 60 degrees. So if you use the 60-degree angle, the x component will be cosine 60 in the negative direction, and the y component will be sine 60. And so see if you can write out what the total electric field is in IJK notation. Pause the video and do that. What I'll do is when you come back, I'll have the answer for you. Okay, you're back. I hope you did the work. If you're not, you're being lazy. We have in the I-hat direction, we have K, Q, remember all the charges are magnitude of Q, over our distance S, S squared. In the I-hat direction, that's E1, it's all x component. Subtracted from that, whoops, did I mislabel? Yes, I did. This is actually E2, my mistake. And this vector in the negative I-hat direction is going to be the same magnitude, but times the cosine of 60. Cosine of 60 is sine of 30, 1/2. So E2 is 1, E1x is 1/2. So when you subtract 1/2 from 1, you end up with a 1/2 I-hat. That's the resultant vector in the I-hat direction. E1 has a y component, E2 doesn't have a y component, so there's only one y component. So we add to that K, Q over S squared times the sine of 30 degrees. That's the square root of 3 over 2. So this one should be the square root of 3 over 2, all that, K, Q over S squared J hat. And it is in the positive J hat direction. So that's the answer you should have gotten. Moving ahead to the square. Pause the video, draw in the vectors, and come back. Okay, you're back. You've got an E1, which is going to be KQ over S squared. You've got an E3, which is equal in magnitude along the y-axis, KQ over S squared. And then you have an E2, which is negative going this way. Turns out to be only half the length because the distance is the square root of 2 times S. And we have to find components for that. So, pause the video. You've seen this problem before as a force problem and in class as a field problem. See if you can solve it. Then come back. Okay, you're back. Here's the answer. In the x direction, remember the magnitude of E1 is KQ over S squared. It's in the I-hat direction. And from that, you're going to subtract the x component of E2. So we're going to subtract the x component of E2. Okay, that's KQ over root 2s squared, right? This distance here is root 2s. When we square it, we get 2s squared. And yet we have to take the sine of the, we have to take the cosine of 45 degrees. Cosine of 45 is root 2 over 2, and that's the I hat component. I'm going to combine that, so it's 1 minus root 2 over 4, I don't have room, all times kq over s squared in the I hat direction. The y component is going to be the same thing, because the y component of E2 is negative. It's going to subtract from E3, and you're going to get the same identical thing in the y hat direction. And the resultant vector is in the positive direction. It will be a vector that looks something like this, the total vector, that vector there. Done.